Hi, everyone. Professor Monty here again. Let's talk about the probability of A or B. Now, when we talk about this probability, let's look back to what sets are. Let's remember what or means. So A or B means any element that is in set A or in set B or in both. Okay, so that's what or means. So I've got an example up here. Suppose we roll a die, regular six-sided die. The possible outcomes are the numbers 1 through 6. I've called event A that the outcome is, the roll is either a 1, 2, or a 3. Event B, the roll is either a 5 or a 6. And event C, it's an even number, either 2, 4, or 6. So let's look at specifically the probability of A or B. Well, what we can do is or usually turns into plus. We call it the addition rule. So probability of A or B is probability of A plus probability of B. And we could do this one by saying, okay, in this case, the probability of this A or B, we would say, well, there's 3 numbers here out of the 6. So the probability of rolling a 1, 2, or 3 is 3 out of 6. Remember the F over N rule. So 3 out of 6. The probability of rolling a B is 2 out of 6. So 2 out of 6. And we would just add those together and get 5 out of 6. And that's our answer. Here's a problem with that, though. Look at, let's say, A and C. So if we did the probability of A or C, and we say, oh, that's the probability of A plus the probability of C. What I'm going to get this time, probability of A, again, 3 out of 6. Plus, well, the probability of C is 3 out of 6 also, which would add up to 6 out of 6, which is 1, which is 100%. But there's a problem. What if I rolled a 5? Well, I've already said I have a 100% chance of either rolling a 1, 2, 3, or a 2, 4, or 6. I never rolled a 5 in here. So the probability can't be 100%. Well, this changes a little bit. What changes is the fact that there was an overlap. In A and C, it had a common number of 2. And so what I have to do, I have to back out anything that they have in common. Well, that's minus the probability of A and C. So what's the probability that both of those happen at the same time? That's any overlap. Oh, A and C would be the number 2 because that's what they have in common. So there is one number in there out of the 6. So it's really 5 out of 6, which is really what we know, because what are the different numbers out of these 6 numbers? 1 would have worked, 2 would have worked, 3 would have worked. Those are all in A. Well, we already counted 2. Let's not count that again. 4 would have worked, 6 would have worked. 5 out of these 6 numbers will work. So we do see that we have a 5 out of 6 chance of this happening in general. So we had to subtract away any overlap or anything they had in common. We didn't have to do that up here because they didn't have anything in common. And in fact, here's the rule. So if this will change this back to a B. Let's erase this stuff as to not get confused. So this probability of A or B, this probability of A plus probability of B works just like that if these are what they call mutually exclusive. So I've got another video on mutually exclusive. I'll link to this at the end of this video. You can watch if you want to. But it essentially means A and B don't have anything in common. So this is true if A and B are mutually exclusive. Probability of A or B in general is the probability of A plus the probability of B. But then you have to subtract away the probability of A and B, any overlap. And this one always works. They would call this the general addition rule, and it always works because even if it's mutually exclusive, this is a 0. And so you'd still have probability of A plus probability of B minus 0. Oh yeah, that's this formula. But if you have an overlap, if they're not mutually exclusive, you have to use this second one. why we say it always works. It's the general addition rule. This would be called the special addition rule. All right, so practice these. Again, I'll link the mutually exclusive video to this so that if you want some more explanation of what that means, you have it. All right, work on this. You can do this, and I'll talk to you again soon.